Okay, welcome to the video on material structure in TP4. It's important to understand how TP deals with materials because we're going to end up wanting to change those materials over time. That always seems to happen in production. Material tweaks happen all the way up until the lighting phase. And then we also just kind of want to have a firm understanding of what operators are involved in creating extra material slots in TP, and then how we can modify those after caching. What happens when we layer caches. So we've got a pretty simple scene out here. This is actually one of our earlier advanced topics where these two objects here fall down and volume break when they collide on the floor. And we also have some simple planes here they're just single objects with 3 material IDs on them. And we also have some unibody humanoid meshes with a MultiSub Object on them. And these two guys, they're not instants, although they share the same material. So different geometry, same material. So TP actually instances materials when you use those. And so one of the reasons that we've got this in here is we want to take a look at what happens when we modify an instance material after caching, and how those changes are going to propagate to every other object who shares that instance material. Okay, so let's just take a look over here in our system right now. We've got, this is the old scene file, so it's just got the birth, where we have the collision environment, the floor, the VB sources, those two objects up here, and then this is just a simple volume activate to tell them to break right away. We're not going to use that, so we'll take that out. And then we also have gravity, and then the shape collision, which is actually going to create the volume breaker cells, and then those cells are going to be used here in volume break in order to cause the VB sources, remember these two objects, to break into pieces. And the most important thing to remember with TP and either fragmenting or volume breaking in materials is that you're going to want to set up your materials here with the material ID. So right now this is set up in such a way that whatever objects these are, these VB source particles, they are all going to use material ID 2 for their interfaces. We've talked about it in some other videos. There's some ways you can kind of customize that on a per object basis. There's a VB mat ID input where you can actually specify per particle what mat ID it should use. That can get a little bit complicated. You've got to use a user-defined properties node to pull user-defined properties off those source objects in Max, store them here in TP, and then you can pass those in either with a data channel or a memory operator. But definitely check out the user-defined properties video for more info on that. That's for customizing that. Okay, so enough of that. Let's go ahead and take a look at what we've got so far. We've got a collision environment, and the collision environment is just this box here. And this box does not have a material on it. We try to pick it, nothing happens, tells us that there is no material. And so what's going to happen is when TP actually brings this object in with object particle, it is going to assign a material to that object, and whether it has one or not, just to kind of create and allocate memory and material space for that particle. And then down here we also have this VB source, and of course it's bringing in 2 objects, and these both have different materials on them. And then looking through the rest of our operators, there's no other shape or object particle, geom instance, or standard shape. So there's not going to be any other material slots created. Let's actually just take a quick break in here and look at, there are some things that we should know. These shapes, we'll just drop out the operators that will actually create material slots in the TP material structure. So anytime we have an object particle, a shape material, a standard shape, or a geom instance, TP is going to create a material slot for that. Now is probably a good time for us to go ahead and look at the TP tree. Let's show TP, and then we'll go ahead and pick TP and get its material. And you can see what it does for us. It's called multi-thinking01. It's based on the name of the object, thinking01. And of course it's a multi-sub object. And you can see it by default, when we pick the actual TP object itself, it allocates a standard material at the top level just for any default particles. This is usually based on the color of the icon, although we've customized it in MaxScript, so it's a little different. But then next up we've got the collision environment, you see right there, and then also VB source. And what it's doing is it's actually using the names of these operators when it creates these multi-sub object trees. So we've got a collision environment, it's a TP multi-sub object. We've got a VB source, which is a TP multi-sub object, and these actually correspond directly to these object particles. So we've got the top level material for TP itself. We've got a multi-sub object here for this object particle, and then another multi-sub object for this object particle. So it's going to do that every time it encounters a object particle. We'll go ahead and create another one. And there's no object in here, of course, so it's not going to update. Let's go ahead and pull this in. Let's pick, I'll say this guy. And we need to instance his shape in order to bring that shape into TP. Okay, and so now you can see it has updated for us, and we've got just called object particle. It's based on the operator name. And if we go inside that, it's a multi-sub object. And the reason it's a multi-sub object is because, of course, object particle can have multiple objects inside of it. And so it has to have a way to kind of allocate extra slots. So, and our guy, of course, has multiple material. He's got his own multi-sub object. So here in our object particle, let's go ahead and see if we can't get that. So inside of our object particle, this particular guy, it's based on his name, or actually the material on that guy, which is just guy. So he's got his own multi-sub object. We go inside here and we can see, okay, well those look like kind of the final material slots for that one specific piece of geometry. We can see that this structure here, obviously the same as this structure, it is just referencing that source material. You can see the little instance icon there. And so if we pick another guy, we get guy mesh 02, and this particular guy mesh 02, he has what's called guy 2 on him. So now if we look, we'll come out of level and jump back in, there's our object particle. Oh, you know what? We did not instance the shape, so it's not showing up yet. So we'll go ahead and do that. Now we get their guy 2. So guy 2 obviously has all of his submaterials there. So just remember, every object particle, it's going to have a TP multi-sub object material assigned to it. So every time there's an operator, an object particle, a shape material, geom instance, standard shape, that is going to create a new slot here for us. Let's go ahead and actually get our other guy over here. Instance his shape. Let's call this guys, and then we'll go ahead and add another object particle for the planes. So we'll pick those ahead of time, just bring this up, pick, and then say changes affect all, because we want to turn all of them into shapes. Let's create some groups for these, because we don't want them really in the shape collision. We'll call these guys, and then we'll have another one for planes. So this object particle, we'll call this planes. Okay, so it's got all those. Changes affect all, and we'll assign that into the planes group. These guys, same thing, changes affect all, go into the guys group. Okay, we'll go ahead and take that stuff out for the moment, and then oops, we're going to update and try to turn all of our TP stuff on. Okay, so now in our material structure we've got the base level material, which TP always assigns to its own object. This is just allocated for standard particles. And we've got a MultiSub Object for each object particle. Inside each of those object particles we have multiple more materials. So MultiSub Objects inside of MultiSub Objects. And this is because our Guy models, of course, have those MultiSub Object materials on them. It's all pretty basic, I'm sure you understand. Okay, so let's go ahead and cache this, and so we can take a look at what happens once we do cache. So we'll just say cache record. We'll use the default name. We'll stick it in our TP cache directory on D drive, and turn off redraw so we don't really need to see that right now. And a little, we'll get into that in a second. I was going to say there's an interesting thing that happens if you press escape while caching. If you hold down escape and in order to cancel the cache, if you hold down escape, it will prevent the MAT file from being written, and that could be a problem. But if you just press escape once and it pops up the little prompt, here we'll do that, we'll say cache record. So we'll press escape once. We get this really cancel. If you say yes at this point, we've gotten up to frame 17, it will actually go ahead and write out that material, the MAT, for you, which can be pretty handy in order to get that structure in there. We'll go ahead and finish that off again. Sorry for that little detour. It's just an interesting point. Holding escape during caching can kind of be bad. I mean, sure, you might really want to cancel it right away, but if you do want that MAT to be created, just press escape once and click on the yes to cancel, and it will create that MAT. Okay, let's turn off our sources. There are our objects there. Let's get our group manager up. In order to modify these, we'll tell them all to displays mesh. We'll tell the guys, we'll do them in kind of a tan color or orangish color. And then the planes, we'll do a purplish color. Alright, so we've got a cache. We've got, if we right click that cache, obviously we're going to get the info about it. We can look at what the path to the TPS is. We've got this nice save material function, and this is really important. We'll talk about that right now. If you're working in a production scene and you keep all of your source objects in here, and someone is modifying materials to these objects, and you've got your cache created, you've locked in your TPS, your simulation looks great, you're done, and you want to go ahead and just update the materials on them. Well, if our guy here has, if we make a change to his material, say his skin color, go ahead and just brighten it up. If you use that, and now you see our icon has changed, telling us that something that affects our caches have changed. Go ahead and hide our sources, show TP. So right now you can see he's got kind of the darker tan skin color. If we use that save material function, what it's going to do is it will actually look at all of the objects in TP, the instance geometry, object particle, the geom instance, and it will actually update the material structure based on whatever the current material is on that object. So this is one really good way that you can do things in production, is if you keep all of your source objects in one big simulation scene. The trick is to get those updated materials into your simulation scene. One way to do that is to use actually XREF objects. That way somebody else can be working on the source file, and you can just pick your source objects, pick those XREF objects, and then when you use that save material function, it will update to whatever the current state of that XREF material is. Okay, so we updated that material skin color. Let's go ahead and step forward now and step back. Okay, so this is the little song and dance that you have to do when you update the material. You cannot actually save material when it's in play mode. What you have to do is you have to say cache stop. Okay, now we will go ahead and say save material. It'll update, and then we'll go ahead and say cache play, and then we'll step forward and then step back. Now you can see those guys' skin colors updated, the material's been updated. So just remember, you cannot update the material in play mode. You have to say cache stop, and then go ahead and just say save material. And unfortunately, right now, in this version, this is TP4 SP1, there is not a MaxScript command to update that save material function. Hopefully sometime soon. Okay, so but just remember, say cache stop, save your material. It will kind of re-ingest and look at the material structures for all these and update them. And then you can go ahead and say cache play again, and then once you update in your timeline, it will update. Okay. All right, so let's go ahead and take a look. We've got this cached dynamic set now. And so every cache dynamic set that has geometry involved is going to have a TPS and an MAT. So one way for us to update those materials is what we just saw. We keep all the source objects, or we use XREF geometry objects, and then we can use that save material function. So that's one way to update the objects and update the materials. Another way is to add an extra dynamic set here at the end, and we're just going to call this one material control. And this one, though, this one's a little dangerous and it doesn't quite offer as much control to it, but we're going to go ahead and kind of hack through this, because a lot of times, you know, you'll have so many objects in your scene that you can do P selection and pick a specific particle and do this, but generally we found that you really want to update at the object level on a per object basis instead of having to pick these. It can be a little bit of work for the lighter to have to do, and it's generally nicer to just kind of supply them with everything already set up. But we'll go ahead and grab our, where is it, material, shape material. So now we're going to add a shape material here, and we'll just duplicate our guy 2. We're going to call it guy 2B. We're just going to make his jacket a different color. Instead of the green jacket, we're going to go kind of a, it's a little too yellow, but that's fine. Okay, and so, oops. So we've got a P selection, we've picked a specific particle, that guy on the far right. We've got a shape material operator, but it needs that material assigned to it, so let's go ahead and drop that in there. An instance of it. That way it's tied to this slot here in the material editor. Whatever changes we make here will be updated into this. Okay, and so now let's go ahead and update, and we can see that we get, of course, our updated guy. So this is one way, one alternative way to update materials, is to actually either do a P selection and assign specific materials to specific particles, or of course we can take an entire particle group, use a shape material, and now our planes, all of those, all get the new material. So this usually works pretty well for things like glass, chrome, anything that's a specific particle group that always has a specific kind of material. But for kind of big beauty shots with characters or buildings, more than likely they're each going to have their own material structure, and so we'll need a way that we can update those. Oh, actually, you know what? Let's interject here and talk about UVs, because UVs are a really not really a dangerous but very important topic with TP. Once you've cached out your simulation in TP, those UVs are locked. And so any changes to UVs need to happen before you simulate. There's one small exception to that, is that if you can actually apply the camera map UV coordinates to objects, and specify your map channel in order to get UVs on an object, even at a particular time. If you wanted to do it at particle birth, we could set that up. But in most cases, you're going to want all of your UVs for all of your objects to be locked before you do your final simulation. Once you do your final simulation, if there's any UV changes, you're going to have to re-record. So hopefully it's not too much of a problem in the pipeline to get those UVs squared away before you actually simulate. Okay, so this is one alternative method. Let's look at the other alternative method, which gets to be a little I won't say messy, but it's kind of like surgery. You remember our cache actually creates an MAT file for us. We can actually open up that MAT. So here's the actual TP material on the TP object itself. In this next slot over, we're going to go ahead and open up a material editor here in our TP cache directory. There is our MAT file for that cache that was created, that dynamic set that was cached. We'll go ahead and open that up, and of course it shows us that material that's in that MAT library. We'll double click that to put it in the slot, and we'll go ahead and just take a look at some of the differences between this cached MAT, which is there, and the actual TP system, which is the object in the scene. So we can tell right away that the names are different. We've got Multithinking 01 and VB System. But more importantly, we can see here on our actual TP object in the scene, we have this entry here for simulation. And this simulation is actually, if we click on that material, is actually our VB system, which is the dynamic set that we cached out. And so this is how TP starts to layer caches and materials, is that it will create a new hierarchy, a material hierarchy, with a TP MultiSub Object anytime you start to cache dynamic sets. And so we see inside that cache dynamic set, the VB system, now these two of course are identical because nothing has changed in there. But okay, so looking at our MAT, we can actually, and remember this, you can tell there's no corner brackets on this material editor slot, and that tells us that this material is actually not used in the scene. I mean, technically it is, because TP here with this cache set to play is actually referencing this TPS, which by default is going to pull in this MAT also. But what we can do, we can actually go in here into that saved MAT. We can see it keeps the particle there, and then it has all of the operators, and all these dynamic sets underneath that cache dynamic set. It keeps all of those there available to us. So we'll look in our birth, and there's all four of our object particles. So collision environment, etc. And so if we wanted to, say, change our guys, let's take a look. We have the two guy materials. Remember, they both had these two guys, this one here and this one here, both had the same material on them. And so they both share that guy too. We're going to go in here and we'll change their jacket. Instead of green, let's go ahead and go kind of a bright blue. Okay. And now here's the thing. Okay, so we've got this material in this slot, and what we need to do is we actually need to save this, put it back into the library, with the same name. Replace it, yes. And then what we need to do is open up that library, and we need to save that. We can just hit save. I'm going to go ahead and say save as, just so I can pick that material. And we want to overwrite that MAT that was created by that cache TPS. So what we're going to do then is this is going to actually update it, and it already exists. We want to replace it, of course. So we'll go ahead and take a look. Now our timestamp is a little bit different. Our MAT has been updated after the fact, and so now what's going to happen is TP is set up right now. It's got this VB system. It's playing that cache dynamic set. So when we start to scrub, it's going to look up that dynamic set, that TPS file. That TPS file is going to pull in the MAT to decide how it should allocate materials to the saved geometry that's in there. And let's actually turn off our material control for the moment, because we don't want to overwrite this guy. And that was the result that we had before. Now once we update this, lo and behold, they now have those green jackets. But I thought we set them to blue. Well, we did. What we have to do is, let's see, what is it? We have to say cache stop, cache play. Okay, so we're going to have to turn off, we're going to have to tell our dynamic set to stop playing that cache, and then we're going to have to go ahead and say cache play. And what that does is it kind of breaks that connection. Once we say cache stop, it's going to stop looking at the TPS, it's going to stop looking at the MAT, and then once we tell it to go ahead and say cache play again, it's going to kind of create that connection again. It's going to load the TPS, that's going to load the MAT, and now we get our updated guys with the blue jackets. Okay, so editing the MAT file is, another alternative to updating materials. That can get pretty hairy though, just because of what happens in really big systems and dynamic sets. You're going to have a really big tree involved, so it's going to be really important to be able to navigate that cleanly. Some hints that'll help you along with that is to actually name your object particles, name any geom instances that you use. If you're going to have big characters or something, once you use these names, these customized operator names, those custom names appear as the material, top level name. Okay, so just a little more fun that we can do, because we really want to kind of take a look at a little bit more complex material system. We'll go ahead and get rid of that cache dynamic set material that was in there. We're going to go ahead and we're going to do some things. We're going to enable our material control, but we're actually going to create a new dynamic set here. We're going to call this Sim2, and in Sim2 we're going to drop that VB system in there. And then we're going to actually leave material control as a sibling of Sim2, but we're going to disable it. And let's actually get rid of that planes material. And then actually where we're headed is we're going to create a Sim3 dynamic set as well, just so that we can kind of stir it up a little bit more. So we've got VB system. This has already been cached, and actually we updated that material, you remember. What we're going to do now is we're going to go ahead and create another rule. Let's actually take a look at our VB that occurs there. So we see those green particles are our VB cells, and these are telling these objects where to volume break. It's kind of controlling the activation. And we can see those interfaces. Of course, we've got the green and yellow here, which is this particular material on that source object, and then the blue and the orange. So material ID 2 in both cases. And now what we're going to do is we're actually going to have our VB chunks are going to emit some more particles because we kind of want to add an extra layer to the simulation and take a look at how that affects the material structure. So we're going to call this add bits, and we'll set this up so that VB frags at birth we'll do it the simple way first, and then we'll make it a little more complicated. So at birth, we want to go ahead and get some surface position information off those actual particle shapes themselves. So we're going to connect the VB frag into the particle shape. Surface position, we want face information, and we're going to leave the UV channel at 0, so it will use all available UV channels. But we will use mat ID 2, so it's only going to birth these new particles on the interfaces. And then we'll go ahead and set this up with position born. We've got a bits group here, and let's actually go ahead and, yeah, I guess that structure will be fine. So these particles are going to be in the bits group. We'll make a pistol shot, just say 50 for now. Some variation in speed, variation in direction, and change that random seed. So the position is going to be controlled by the surface position. Each one of these VB frags is going to be creating these particles, and those particles are only going to get created, and this operator will be turned on at particle birth. So when these frags are born, this is going to come out true. It's going to create those bits. And then the bits themselves, we're going to want a standard shape on those. And we're going to go ahead and rename this bits shapes, just to keep with our kind of custom naming of operators that affect our material tree. That way it's going to be easier for us to navigate later if we have to edit the MAT. It's a really good idea to keep all of your source objects in one simulation scene. Using the save material is probably the easiest way to update materials in TP, so I highly recommend using this whenever possible. And again, if people are going to be updating your materials constantly, either in modeling or in lighting, lighting is a little bit different. We'll talk about modeling first. Modeling using XREF objects actually has worked out pretty well in quite a few productions. You're able to keep those objects in TP, and it will just go ahead and use whatever latest material is applied to that XREF object. Once you hand off, well, if you're in a pipeline that is using the TPS and the MAT, and you just hand those to a lighter, somebody who's rendering your scene, that's going to be a little bit more difficult for them to update the materials on those objects. It'll probably come back to you, in which case you would just go into your source scene, use that save material function. But if you're going to be handing it to a lighter, a material control kind of rule is a really easy way to allow a lighter to modify things. This is such a simple setup, just using a P selection to pick particular particles, as long as they pick the right one, and then assigning a shape material and being able to override that. And lighters have no problem also, modifying entire particle groups. That's all pretty straightforward. The problem is if you try to get into a situation where you're going to have someone modifying the MAT, like I said, that can just get so complicated because there's so many different layers involved. You've got layers for each simulation or dynamic set that you cache, and then inside that dynamic set cache you're going to have all of your source operators, anything involving geometry or materials. And so inside those you're going to have to pick the specific object that you want to modify, whether it's this particular mesh or this one. So that can get pretty hairy to kind of manage and pretty difficult. So definitely recommend you try to use the save material function whenever possible. Okay, enough of all that. Let's go ahead, and we've got our add bits rule. Let's go ahead and put a material on this. Or actually, you know what, let's not and we'll take a look and see what happens when TP does this for us. Without a material, it still needs to allocate a material. We'll go ahead and turn off our material control, and then we'll go ahead and cache our sim2 file. And actually, let's check our bits. I think we're going to want to control our size. Let's say anywhere from 3 and some variation there. Okay, so sim2, let's cache record that. We'll just call this sim2 TPS, accept the default names. That's a pretty good way to go. And of course, our redraw is turned off. That can often save you some caching time, keeping your redraw turned off. Unfortunately, you just don't get to watch it. Okay, so these objects come down and boom. Once they start to collide, now we can see those bits being created. Those are actually kind of in a greenish color. Let's go ahead and make that something a little more lively and visible. I know red doesn't compress too well, so blue will be fine. That's good. Okay, so we've got our second rule here, add bits. So now we've got one cache dynamic set, some modification to that. That's been cached in sim2. So sim2 now contains these two rules cached together. And we'll go ahead now and we'll open up that sim2 mat library, which is right there. Drop this in here. Okay, so sim2 right now, this is just, all of the contents of this particular dynamic set, which contains by default, a TP particle, so a material for the TP system itself. And then we also have the simulation. And lo and behold, it did not create that slot for us. So let's go ahead and redo this. And actually, let's give this, let's create a little material called bits. Drop that in. So that could be a problem. If you're going to end up using standard shape, you're probably going to want some kind of material placed in here. And I would say the preference would be not an instance material, so a unique material, just in case you need to modify these objects being created later. Let's also make these cubes. Okay, sorry about that. We're going to have to go ahead and cache again. Cache record. We'll be right back. Okay, let's jump back in. And so here are our objects. Those guys create those blue bits particles. This is no longer going to be accurate. We're going to have to go ahead and open up that material library again. Do that. Drop that into that slot. Okay, so now what we get here in this actual sim2, we get the simulation, which is this VB system, this cached dynamic set right there. And then we also have this add bits, where this rule now is showing up here in this bits shapes that we've got, which contains the actual bits material that we had created. Okay, so inside that simulation, which is the VB system, this one right here, VB system, again, we've got that default TP material, and then all of the object particles, each broken out with their own object-specific materials that are applied to those source objects in the object particle. Okay, so it starts to get a little bit hairier. Let's go ahead and make it even more interesting. Let's go ahead and turn on the material control and set ourselves up to with another cache. We're going to go ahead and say sim3. We'll go ahead and cache this. And this time what we're doing is we are caching our sim2 result and combining it with this this p selection material override on I think it's this particular guy right over here. Let's actually update that. Yeah, that's what it is. And actually, let's also, just for kicks, we'll go ahead and modify our, and this is Yeah, this is going to lead to a little issue, but we're going to go ahead and modify the source object for this VB kind of source object. And what we're going to do is we're going to apply just the red, green, blue MultiSub object. Now, what's going to happen is this particle right now, it's got an override on it. It's using that shape material. But what happens is once it fragments, you can see it's going to show up red. Once it fragments, the frags are going to revert back and use you know, that original material that was applied to them. So this, you know, overriding that kind of behavior can be pretty difficult. You'd have to set up a rule where the fragments, say these fragments here, you could set up these frags with a memory or a reference. I kind of prefer memory over reference. Reference is broken in a couple of cases. Memory seems to be pretty stable. So you could create something like a myParticle input, so that when these VB sources fragment with and create some VB frags, those VB frags actually store, hey, who was my parent? Okay. And so then, what would happen is these fragments in orange or yellow here, they would remember, hey, this is my source object. Okay. So then you could say in some rule later on, or actually, you know what, I'm sorry, this is a little bit dangerous, because using it in memory is fine if you're all within the same dynamic set. Unfortunately, once you cache, all that memory information's gone. So you would actually, in this case, probably want to use a data channel. And you might actually store, let's use an integer here, call my parent as an integer there. So that'll be an int, that'll come in here from the particle ID. And so the volume breaker frag could remember, hey, I came from this particular object. And then what you could do here in the material controls, you could say, oh, okay, well, yeah, in this particular case, you'd have to do something like VB frags, do a threshold test on my parent. And then you could actually override their material on the VB frags. You know, before we get too far into wiring all this, let's go ahead and actually do this just as a fun example. We'll go ahead and turn off our material control rule. We're going to have to turn off our cache stop, our sim2. We'll turn off the bits just because we don't really need that. What we have to do is we have to go back to the basic VB system, recache this now so that all of these volume breaker frags remember the ID of their parent. And particle IDs are integers, so that's why we store this into an int data channel. So and our VB frags are set up with that data channel to be recorded, so we're all good. Yeah, remember, the nice thing about data channels, they get stored in the cache file. Memory values do not. So reference values actually do also get stored in the cache, which is nice. But like I said, there's actually a limitation using psearch. If you have particles comparing a particle comparing its get reference with the found PID get reference, that can run into issues. But anyway, back to the task at hand. Let's go ahead and record. So now when our VB frags are created, they remember who they came from. And of course redraw is off to kind of speed things up. We get those there. Okay, these come down, they break, that's all good. And of course they have their old original source materials on them. Now what we're going to do, we're going to enable that add bits rule, and then we're going to go ahead and, because we want to get those bits created. And actually, you know, looking forward, what we should do is we should create a data channel on bits also. We'll create another one called myParent. And we'll do kind of the same thing. We'll just go ahead and store so that all these bits, let's actually rename this to bits. It's a little bit better to manage our operators, our generators here, so we know which group is being created. Hopefully someday we'll have like automatic name readouts and stuff. But okay, so we're going to store this into data channel 0 for these bits particles. Data channel 0 is an integer. We're going to store those VB frags. So the frags have a parent that they remember up here with that data channel. But the bits just care, hey, which frag did I, or which VB frag. Although actually, it might be better. Let's do this. Because what we're thinking is we want these bits to be based on the source material of the parent object, not the VB frag itself, but the actual parent, so that if its material changes, we can modify the bits for that source object. So what we're going to do is we're actually not going to take the data channel from the frag, but from the parent. So both the VB frag and the bits are both going to know, hey, I came from this source object. Okay, so let's go ahead then and we'll record this next layer. And we'll be right back. Okay, so we're back now, and let's go ahead and see. These guys come down, they fall, break, and we're getting some bits here. Let's actually show the bits, not as dots, but show their mesh. Okay, now you remember our bits material was this just standard gray. And let's just go ahead and do this because we want to test a little hypothesis at the moment. I'm going to go ahead and set our bits to be, let's do a purple color. Remember, we're going to try to update our material. We'll say cache stop. Now save material. I'm just going to update the whole material structure, and then we'll say cache play, and then we need to step through a timeline again to update that. And lo and behold, look at that, we get the purple material on our bits. So it went ahead and updated this material slot here. But now what we want to do is we want to go ahead and use the material control rule. And look, we've got a little something going on there. Let me clean this up a little so that I'm not overriding what I'm not supposed to. For now, let's go ahead and take this particular guy over here on the right. We'll pick him, and we want him to use, is it multi-test 1? No, actually for that guy on the right, we're going to want to go ahead and use this guy 2B. So put that slot there. Okay, so he updates, he looks good. And then we'll go ahead and also, we will change our VB frags. Or actually, let's do this. Let's start with the source object itself. So we're going to say we want to modify this source object, this guy on the left here, and we want it to use this multi-test 1 material. Okay, so now this should turn bright red, and there that is. Okay, but what happens is when it comes down and hits on there, we get our bits showing up, that's all fine, but our source VB frags, you can see, well, our source object's red, but these frags, we've got blue and this orange in here. That's not really going to look too good when we render it, because it's going to change all of a sudden. So what we're going to do is actually set up a new kind of source material object. We'll just duplicate this guy, put it over here, tic-tac 2B, and what we'll do is we'll take this material as an instance, and we'll drop it in that object there. So this is our new object material. And what we're going to do is we're going to modify our VB frags, since those are the particles that we're trying to modify here, these guys who turn blue. So VB frags, we want to test, hey, if their parent is a certain one, then go ahead and change that material, because we want to modify this parent object frags and not these frags over here on the right. So let's go ahead and do this. Let's say display our source objects as PID and turn off their mesh. So we've got particle 7 and particle 8. So we'll take particle 7 and we'll test, hey, if I am inside 7, then go ahead and update that material. And the material that we want to use now is this one right here that's got the red on the outside and that orange on the inside still. And then we'll go ahead and tell our sources to go back to their display mode. Okay, so now, Houston, do we have a problem? Our VB frags, let's go ahead and check this. Maybe we need to do this integer tweak. This is interesting. We get some of them up here doing that, but not quite what we were expecting. Let's go ahead and see. Let's go ahead and tell our bits to not show their mesh, but just as dots. Okay, let's go ahead and we'll fire up debug, see what's going on. Okay, so it's writing out ID 1 for all of these. Let's take a look back at our source here. This VB source. Let's go ahead and set this to 1 and 1. And then we'll turn off debug. Well, that's a little odd and disconcerting. You have witnessed a potential problem. The particle ID that we'd try to display on VB source is not the particle ID that is being stored in the data channel. So we'll have to dig into that a little bit later. But anyway, you can see now that we have turned on debug and we see what the parent ID information is coming out of there. And actually, let's go ahead and turn that on again just so that we can see the one on the right hand side also. So this guy breaks first, obviously it's ID 1, and then we get a whole bunch of ID 2s also for this guy on the right. But that's just not right. It shouldn't be those should not be the actual ID numbers, because their particle IDs are actually 7 and 8. So strange. We'll have to hunt that down. Okay, we'll turn off debug. So storing our data channel, storing our parent, and then testing for that parent ID, and then overriding our material to match. It's kind of a long, convoluted method to do it, but it does give you that kind of control to be able to track the history of a particle, where it came from, who was my parent, who was his parent, etc. Okay, and then so finally, let's go ahead and record our sim3. And sim3 now is going to actually take our sim2 that we had, and it's actually going to bake in those material changes that we had made. And then we'll go ahead and take a look at that material structure and talk about it. So we'll be right back. Okay, and here we are. Let's go ahead and open a material library for sim3 that we just recorded there. Let's open that. There's our material. Okay, so sim3 contains our sim2 file, this simulation here, sim2, and then it also contains 3 shape materials, which is what we see in all of these here. So we've got kind of a direct correspondence. We have guy2b, we've got where is it, the tic-tac was being applied. Oh, there it is. This is... Oh, so here's an interesting little thing. The order of this operator, this shape operator, even though spatially it's down here, it's actually located here in the tree. And so the last shape material is going to be applied down here. So just another way that ordering of operators has an effect on TP. Go ahead and update ourselves so that we can actually keep that visually cohesive. Alright, so we've got the simulation, which contains sim2. Inside sim2, of course, we have another simulation, which is this cache. That's just how TP refers to cache dynamic sets, simulation, where we've got the VB system, all of its contents here. We'll go up a level to sim2. We can see that we've got a bits shape, standard shape there. And of course it is simply a, this standard shape can only hold one material, so that's why it's not a MultiSub Object. Okay, and so then we come up, we've got sim2, let's come up out of that, and then so we can see that the ordering and the structuring of these is, it's pretty logical actually. It has to keep track of, hey, what has already been simmed before, what additional materials do I need to allocate, and then if it's a shape material, you know, a shape material only has one slot, so these are actually only one slot. It just happens to be a MultiSub Object material that was placed in here. Okay, so if we wanted to now modify this MAT, our sim3 MAT, you know, we're in it right here, we could actually go ahead and which guy? Let's go ahead and modify the guy down here because he's pretty easy to pick out. If we were to modify this shape material here and try to modify those, which one is this being applied to? I think that's actually, oh, that's actually that object. If we were to change this, it would end up changing the outer color, and then it would not match the VB frags. So we're going to avoid that for the moment. We're just going to go ahead and modify guy 2B again. We'll take his jacket, instead of doing a kind of a tan, let's go back to kind of a richer blue. And then again, we're going to go ahead and put this back into the material library, but it already exists, of course. So we'll replace. And then we've got our mat library, contains that updated material that we just put back in the library, but we need to save this. And you can see here, we're looking at the material browser for sim3.mat, which is referencing that external file. So we'll go ahead and just say save, close, and then of course remember we need to turn this off and then turn it back on. And now our guy updates. Okay, so that's kind of a large roundabout discussion on materials in TP. Just remember that there is logic to the madness, and those material trees, they can get very large and very hairy, especially when you have materials being updated constantly through a production. So I'd highly recommend using either XREF objects or working out a method to update your materials on the source objects, and then use the save material function in your master simulation scene. But if you can't do that, then you know you can always have lighters set up a P selection to pick specific particles, override their material with the shape material node, or just modify entire groups with their shape materials. Okay, so we're going to go ahead and save this out as the end scene. And if that doesn't hurt your head, let's go try something else.